So now I've got question number 10 from this question paper, and they've given us a graph. Now, something you must always remember, if you're ever given a diagram, a graph, a table, and so forth, your answers must come from that table, right? You cannot bring in answers that were not given. For an example, let's go back to the previous question. When they asked us what color was radiated, looking at the wavelengths answer that I got, I was able to say, aha, this is the color that came because the wavelengths were exactly the same. I didn't say, I think if I look at the electromagnetic spectrum, and then you speculate. You must use what you're given. The examiner wants to show or see whether you can use the information given and actually prove your answer. It was already given to you. We just had to prove it. So it's the same thing with in this diagram. So for this one, we are given, it says that the graph below is obtained for an experiment on the photoelectric effect using different frequencies. Now we know when we talk about frequencies, they actually do have an effect. Frequencies of light of a given metal. They didn't tell us what metal it is. We also know that different metals will have different work functions. So looking at this graph, I know that's my kinetic energy. Remember that kinetic energy is the energy that the electron will have to actually move around. Here I've got 0. So from this line here should be my threshold frequency, and moving over would then be the energy that it will have. I can see that this is my frequency, and my frequency is times 10 to the 14, and it is already measured in hertz. And then I've got 6.8, which means that must then be my threshold frequency from the metal plate. That is all that I can see. I'm given some form of information. Everything that I answer must come from this diagram. Let's move down. So the question here says, it says the threshold frequency of the metal is 6.8. Now, one thing that you must always remember, you're gonna have some clues in your question. So here they're telling us the threshold frequency. They've already given us to us. They've given us the graph. So they're already saying, please use the threshold frequency. And in the next question, they say, define the term threshold frequency. Now, the word define is a very crucial word in physical sciences and in chemistry. For an example, if I said to Mbali, Mbali, define what your favorite holiday is going to be. Mbali can say, I like rock climbing tops. I want to be sweaty and I want to feel the sun and feel the breeze. And I can say, oh, Mbali, my type of holiday, I want to be lying on the beach, you know? So how you explain depends on your own discretion. But if you have to define something, it means it's something that does not change. It'll always be the same. If you can page through any textbook, all definitions will be the same. If you had to give the laws of something, for example, Newton's laws, they don't change just because you go in different parts of Africa, they remain the same, right? We use them differently, but Newton's laws remain. When we talk about phenomenons that happen or phenomenons in physics, they remain the same. It's the same thing as constants like the speed of light, Planck's constant, it will always remain the same. A definition, unfortunately, is something that you must know off by heart. And actually, if you think about it, if you had about 10 definitions and each were for 2 marks, you're already banking like 20 marks in your exam paper out of 150. So that is really marks you cannot lose. So please don't fail because you were lazy to read. So the first one says we must define the term threshold frequency. Now, this is how we define the term threshold frequency. Remember, every time you are defining, the examiner is looking for certain terminologies. So this will be 10.1. I'm going to give you 2 definitions. So the first definition that you can use is that it is the minimum. It is the minimum frequency of light, needed to emit electrons, from a certain metal surface. This is the one that you can use. Make sure that it is exactly like this. They are looking for keywords, but this is the first one. Or, let me write it in a different color. Or, you could also say that the threshold frequency is the minimum frequency of light below which electrons will not be emitted from the surface of a certain metal. So most of the time, memorandums will either have either or, but also if your teacher has something else that is correct, you're more than welcome. So we can either say the threshold frequency is the minimum frequency of light needed to emit electrons from a certain metal surface, or we can say it is the minimum frequency of light below which electrons will not be emitted from the surface of a metal, which is true because remember, when we have different metals, they have different frequencies that are required so electrons can be emitted. So if the frequency doesn't really cut it, then the electron's going to be like, nah, I'm not moving, and then it stays. Then, nah. But if the frequency is enough, then the electron is able to be emitted off the metal surface. So threshold heat frequency is the minimum amount of energy that is required to emit that electron. Now remember that metals will differ, so always keep that in mind. So that's 10.1. So let's see the other question that we need to answer. The next question says, or information says, in the experiment, the brightness of light. Now we know the brightness of light comes with frequency. However, I just want to write here that the brightness only increases. Brightness increases the number of ejected electrons. Now I love ejected electrons. I love working on questions like this so that when I answer, it makes sense. Remember, if we increase the brightness of light, it means that I just have more electrons that are going to be emitted. But when we do the photoelectric effect, one of the most important things, or why it's usually done, is so that we can generate current. In order for us to generate current, these electrons must have enough kinetic energy so they can actually move around and they can generate current. And by moving around and generating current, they require energy. So that is the whole point that we need. So increasing brightness means I'm going to have more electrons, but not meaning that these electrons are going to have enough kinetic energy to actually move around. So you must be sure when they're talking about brightness, what does brightness actually affect and what does brightness actually do? So now let's see what they're actually asking us about the brightness now. So in 10.2 it says, state how this change will influence, the speed of the photoelectrons. And that is for 1 mark. And it says choose from increases, decreases, or remains the same. Now guys, if they've given you something like this, please do not go write other words. Like the electrons will not change the speed. They say choose from this. The examiner wants to see whether you can read. Remember? So you don't want to get your answer right, but because you didn't use the correct terminology, then get your answer wrong. So from this case, brightness only increases the number of ejected electrons. So how will the brightness affect or influence the photoelectrons that are emitted? It will then remains unchanged. Let's put it exactly as they have, and let's phrase it exactly as they have. I'm going to write it here. Remains unchanged. Remember to stick with the wording that they have given you. Do not try to spice it up and then use something else. So let's look at our next question. So now 10.3 says, show by means of calculation. So the examiner wants to see calculations, and they are 5 marks, whether the photoelectric effect will be observed or not observed. Just go back. It will be observed or not observed if the monochromatic light with a wavelength, that's the wavelength given, of 6 times 10 to the negative 7 meters is used in this experiment. Let's just go back. I'm going to tell you how you should tackle a question like this. Here, this is our first clue. We were given a certain metal. They didn't tell us. They just said a given metal. They told us that the frequency of this metal, the threshold frequency of the metal, is 6.8. Now they are telling us that we need to calculate if we used a wavelength of 6 times 10 to the 7 meters in the experiment, whether the photoelectric effect will be observed or not observed. Now, this is how you need to think. You need to see whether something is going to happen or it's not going to happen. How do we know this in the photoelectric effect? If we have a certain metal and we have the threshold frequency is enough to eject the electron, then photoelectric effect is going to occur. Now that's frequency. With these two, I can then see with this wavelength and the frequency given on the table, I can work with those two frequencies and then see whether the threshold frequency and the frequency of this wavelength is going to be less or more. And then I'm able to say with conclusion that the photoelectric effect will be observed or not observed using frequency. The second way, I know that every type of metal has its own work function, which means it's different types of energies that are required to emit electrons from that metal surface, which means with the diagram that I'm given, I can use that frequency and see how much energy will that photoelectron have. Then again, I can use, in question 10.3, they've given me the wavelength, and I can see with that wavelength, how much energy will this photoelectron have, or the work function. Then I can say whether the energy that the electron will have is less or more than the work function required for that metal. That is now using a work function. Another one that I can use, I can say, on the diagram that I'm given the frequency, but then I can find with the frequency in my diagram, what is then the wavelength in correspondence to the wavelength that I'm given. Does the wavelength of that frequency, is it less or more with the monochromatic light wavelength that I'm given? Then I'm able to say whether it's more or less. Then I can then conclude whether the photoelectric effect is going to be observed or not observed. So those are three ways that you can do it. And how did I get to these three ways? Looking at the equation E is equal to HF and H being C over V. I can use energy, I can use frequency, and I can use lambda to actually prove whether it would happen. Remember, I don't have so much information, but I do have a lot of constants that I can use when dealing with the photoelectric effect. So I'm going to do it in three ways, and we're going to conclude in three ways, depending on which way you were thinking. But let's see how you are thinking and how you're going to work with. So now let's see. For the first one, I'm going to use frequency. So I'm just going to write option number 1 here. We know that the speed of light is c is equal to f lambda. Now I'm going to use frequency. When I use frequency, I'm going to say frequency, making it the subject of the formula. I'm going to get c over lambda. Now c is the speed of light, which is 3 times 10 to the exponent 8 all over. The lambda that I'm given is the one that I'm given here. They're telling me that this monochromatic light has got a wavelength of 6 times 10 to the negative 7. So let's see what my frequency will be in correspondence to this frequency. So I'm going to use lambda of 6 times 10 to the negative 7. Let's see what my frequency will be. On my calculator, I've got 3 times 10 to the exponent 8. Close my bracket. Let me just go back. I must bring it down. At the bottom, I'm going to have 6 times 10 to the exponent negative 7. Let's bring that down. And let's see. Then I get a wavelength of 5 times 10 to the exponent 14, which is 5 times 10 to the exponent 14. Remember, frequency is measured in hertz. Now let's conclude. I can then say, remember, when you conclude, you have to write a statement and then conclude. Now remember, this is the frequency that I've got. We need to do it in comparison with this frequency that we're given here. You can already see that the frequency that the electron will have and the threshold frequency is not the same. The threshold frequency is greater than that frequency. So let's see, or how are we going to conclude? We can then say the value of f is less than the threshold frequency. So it means the minimum energy required is not even close to the energy that it'll have. It's less than the threshold frequency. And they said we need to conclude whether the photoelectric effect will be observed or not. So we can say the photoelectric effect is not observed. Photoelectric effect is not observed. That is the first one. Let's see another way that we could have done it. Another way we could have looked at the work function and the energy that it'll have. So I could say for the given metal, which is on the diagram, I can say the threshold frequency, and I can use HFO. I want to find the work function of it. Now I know that H is a constant, which is 6.63 times 10 to the negative 34. And then the threshold frequency of the given metal on the diagram is 6.8 times 10 to the exponent 14. Now let's see the work function, and we can do that in comparison with the energy that it will have. So let's see what we're going to get there. I've got 6.63 times 10 to the exponent negative 34. I need to multiply that with 6.8 times 10 to the exponent 14. Now let's see what my work function is going to be. I get 4.5. Now I must round it off to 2 decimal places. So it's 508. The 8 is greater than 5, which means it's going to round off the 0 into a 1, and that is times 10 to the negative 19. So the work function that I'm going to have here is 4.51 times 10 to the negative 19, and work function is measured in joules. That is for the given. Now let's look at the given wavelength. Now the given wavelength of the light that we have, let's see what we're going to have. I can then find from the given wavelength, how much energy will this photon have? Because if the work function and this does not correspond, it means that it's not going to work. Energy of a photon, I can then, skipping a step here, I'm going to have lambda. Just in case you're confused, remember we have HF, and I know frequency is C over lambda, and that is how I got to that. And then H is a constant, which is 6.63 times 10 to the negative 34. My C is the speed of light, and it's a constant, which is 3 times 10 to the exponent 8. And the lambda that I'm given is 6 times 10. It's 6 times 10. It's 6 times 10 to the exponent negative 7 for this light that we are given. Now let's see whether the energy and the work function are going to work hand in hand. Put it as it is in your calculator. Remember to put brackets, 6.63 times 10 to the exponent negative 34. Bring that down. I've got 3 times 10 to the exponent 8. At the bottom, I'm going to have 6 times 10 to the exponent negative 7. Close that. Now I get 3.315, remember, to 2 decimal places. The 5 will change the 1 into a 2, so that's 3.32 times 10 to the negative 19, where I get 3.32 times 10 to the negative 19 joules. Now look at this. The work function is 4.51, but the energy that the photon have is 3.32, which means the energy that the electron or the photon will have is much less than the work function. So we are not going to see. So this means, now let's conclude. I can then say the energy is less than the work function of that metal, is less than the work function. Now let's do our final conclusion, the photoelectric effect. Photoelectric effect is not observed. Is not observed. I've got rainbow colors. So that's another way we can do it. Now let's look at the third way in which we can do it. So now I'm going to use the 2 lambdas. So this is our third option. Now I want to see with the wavelength of this frequency and the wavelength that I am given here. So now I want to look at the wavelength of the threshold frequency and then the wavelength of this monochromatic light, the lambda of it, what will it be? Is it going to be more, less? And after that, I can therefore conclude. So what I can start with, I can say that if I look at the speed of light and I look at the threshold frequency and lambda, if I'm looking for lambda, I'm going to say lambda is equal to C over threshold frequency. C is a constant, which is 3 times 10 to the exponent 8. The frequency that I'm given is 6.8 times 10 to the 14, right? That is the threshold frequency I'm given of the system. So let's see what am I going to get in correspondence to the wavelength of the monochromatic light. So at the top, I have 3 times 10 to the exponent 8. go backspace. Let's just bring that down again. At the bottom, I'm going to have 6.8. This is the threshold frequency times 10 to the exponent 14. Bring that down. I'm going to click that there. So now I've got all these numbers. Let's see, I've got 1, 2, 3, 4, 5, 6 zeros in front. So I've got 0, 1, 2, 3, 4, 5, 6. And that is 4, 1. I'm going to move my comma 1, 2, 3, 4, 5, 6, 7. So that becomes 4.1. 4.1 times 10. 4.41 times 10 to the exponent negative 7. And remember, lambda is measured in meters. Now I can conclude with the statement to say that, remember, we had the threshold frequency, which was the 6.4, that was 6 times 10 to the 7. So we can say that the threshold frequency, we can say the threshold wavelength, rather, we can say the threshold wavelength is smaller than 6 times 10 to the negative 7. Now let's conclude, which means the photoelectric effect, electric effect is not observed. Okay, those are the three methods that you could have looked at it in terms of frequency, lambda, and the energy and the work function that was required. Now remember, you can use any one of these, but what the examiner wanted to see was that you needed to use the diagram that you were given, the information of the monochromatic light, and see how does it correspond or correlate with one another. So you get those marks. You get a mark for using a formula, for substituting the correct information, for actually looking and taking the correct information from both parties, as well as you get a mark for actually concluding to say that no, man, the threshold frequency was less or more than this, therefore the photoelectric effect will not be observed. Remember, it's like you're writing a statement. The examiner wants you to prove something and then give you a final conclusion with what you have proved. So whatever you're going to write to say that it won't be observed, they must go back to your answer and see whether you've proved it or not. That is what they're looking for. So you could have used any of these three ways to actually find your answer. So that was okay. So let's see another question. I think we have one more question that we're going to have. Let's just try go down. So now here it says one of the radiations used in this experiment has a frequency of 7 times 10, and that is in hertz. That's the frequency that is used. Now we must calculate the maximum speed. Now remember, of the speed of any ejected photoelectron, it means that we're calculating kinetic energy. The movement of electrons is what we call kinetic energy. We are given a frequency, we must find the maximum speed of the ejected photoelectron. So now there's various ways that you could actually use it, but in this case, we are only given minimum amount of information. We are only given the frequency. So in your mind, it must already come back from what we did in grade 11, when we actually have the mass of electrons and so forth. So keep that in mind. So we're bringing in a little bit of grade 11 information here and what we have done. So let's calculate the maximum speed of what we can have. So I'm going to break it down for you. It's only for 5 marks, but I think it's always nice that you actually show the examiner everything that you're doing and where it comes from. So this is a standard formula that we use, which is E is equal to work function plus kinetic energy. But my energy, I don't have the energy, but I know that I can break up my energy to HF because I was given the frequency. With my work function, I also know it's H with my threshold frequency, plus kinetic energy is a half mv squared. Now I am looking for the V. Everything else here I can have. H is a constant, which is 6.63 times 10 to the negative 34. The frequency that I'm given is 7.8 times 10 to the 14 equals. The H is a constant, which is 6.63 times 10 negative 34. The frequency that I'm given in the original one, the threshold frequency of the metal is 6.8 times 10 to the 14. Remember, now they just changed the frequencies, and this is a half mv squared. I'm looking for my V. This is what I'm going to do. I'm going to take this part to the other side. Okay, let me work it out like this. I'm going to take this part to the other side and then subtract them. So because I'm running out of time, I'm just going to tell you what you need to get. You should get 6.63 times 10 to the negative 20. And on this side, you're still going to have half mv squared. Now I'm going to have 6.63 times 10 to the negative 20. I can't have two unknowns. I'm going to use the mass of an electron, which is 9.11 times 10 to the negative 31. Now I only have one unknown, which is my v. Now I'm going to multiply a half with 9.11 times 10 to the negative 31 and divide it on this side. I'm going to have v squared is equal to 1.455543359 times 10 to the 11. If you put this whole number under a square root, your velocity or the speed should then be 3.82 times 10 to the exponent 5, and your speed is in meters per second. So that is in what the examiner wanted to see. You had to use the correct formula and then find your speed and then conclude. The only difficult thing here was that you needed to bring in the mass of an electron, is what we learned in grade 10 and mostly in grade 11.